Hello, you're going to be joining me on the adventure that will be known as Fundamentals of Software Engineering in Vancouver in the fall of 2022. I am Juancho. The learning objectives of this course or of this particular lesson are you should be able to explain in general terms what software engineering is. You should be able to explain and understand what your weekly obligations are as a student, and you should have a good understanding of what the requirements for this course are. So, who am I? I'm Juancho. I'm your instructor. We will be, I have office hours on Tuesdays and Thursdays. They're available through bookings. What have I done in my life? I grew up in Colombia, South America, and I have worked both in academia and industry. At industry, I was worked at EA, THQ. I worked at Amazon in AWS, Alexa, and Amazon Retail. Then I worked at a small company called Hothead here in Vancouver, and I worked for a German company called Staffbase that does business type of software. From the academic perspective, I've been at the University of Alberta, where I investigated non-photorealistic rendering, at Carnegie Mellon, where I did game sketching. Currently, I'm very, very much interested in how we can provide tools for software engineering teams. My current role is professor of the practice here at Northeastern University. So, the purpose of this particular lecture is to just give you an overview of how we're going to collaborate in this class. First of all, this course and all of the courses here at Northeastern in Vancouver are hybrid. This means that I expect you to spend time in advance of the course watching videos, reading material, preparing presentations. I want you to come to the class prepared to collaborate in the class. The classes are not a repeat of the lectures. The classes are, in fact, working sessions intended to help you solidify your knowledge of the material. This is a full-time course. That means it's about 20 hours a week, 12 to 20 hours a week. And we are going to be building a project over the extent of the semester. So that means it requires your constant attention. You cannot finish the project as a team in the last 2 weeks of the semester. This course is about software engineering. You have spent a lot of time in preparation for this course learning how to program. Programming, believe it or not, is the easy part of this job. Software engineering is the process of building large bodies of software, i.e., lots of programming, and it's the tools that we use to design, construct, maintain programs. How do things like Microsoft Word evolve? How are they? What does the team for Microsoft Word do? Et cetera, et cetera. So essentially, and there's different varieties of this. Software engineering has to manage the life cycle of the software. So you can start anywhere you want on this, but typically, let's say we start at the top. We write write and refine some requirements. Then we create some tests. Some people will write a proof of concept here. Other people will do the design and then write the test. So these two things here are interchangeable. Then you write some code. Then you debug and make sure that your code passes your tests. And then you deploy and collect feedback, and then you update it and say, oh, we have a bug, or the feature didn't work as possible, and then you go around that cycle again and again and again, right? So how big is each cycle, right? So for something like a video game like FIFA 2024, the cycle is 1 year. For something like Google Docs or Google Mail, the cycle may be a lot shorter. How do you manage this? Can you have multiple cycles? When I was working for Alexa, I managed a team of 10 engineers, but we were part of a team of 250 engineers, and so there's about 25 managers that were all having different components of Alexa being built. So how do we do that? How do we, for each cycle, what do we build for the next time, and how do we measure whether that's done? This is all part of what you're going to experience in this course. The answer to how big these are and how small they are is depending on the team, depending on the project, depending on how long the project's going to be around. There is no right way. So if anybody ever tells you that there is a right way to run a software engineering project, you immediately know that they are wrong. Every team I've worked with has implemented their processes, their methodologies in slightly different ways, because every product that every team is building is slightly different. So we expect teams to be constantly analyzing how they're working and changing how they do that. And one of the things that you're going to have in this course is a team charter, and that will help you do that. And you're also going to be doing weekly retrospectives such that you can adopt your best practices. You've learned to program, you write a program, and your compiler takes that program and converts it into executable code that then the runs on the computer. That's great. Now, at some point, you're going to write some code, and you look at it 6 months, maybe an hour later or 2 weeks later, but you are going to write some code, and 6 months later, you're going to go, ooh, I don't understand that. When you are writing software as part of a team, not just for a assignment for a professor, you are writing code that may last 15, 20, 30, 40 years in that repository that needs to be understood by yourself, by your team members, and by future team members who take over that code. So as Martin Fowler said here, any fool can write code that the computer can understand. Compilers are remarkably good at taking syntactically correct code and converting it into machine language. However, I can write really, really horrible code that you will not be able to understand. The whole point of software engineering is working and writing code for other people such that they can read your code and understand what you're trying to do. So the first part of what we're going to learn together here is that you want to write your code for other people. The second part is that when you write code, your mind is in a particular frame of reference. You finish your code and it works, and you step away from that, that frame of reference disappears. Now, when you go back to debug that code, there's a whole bunch of context that doesn't exist anymore. Kernighan, who's one of the early pioneers of software engineering, said that if you write that debugging is twice as hard as writing code. I think it's about 10 times as hard, but that's okay. But basically, if you write the code as cleverly as possible, if you write the best, the most smartest, and the cruftiest code possible, you're not actually smart enough to debug it. So your goal is to write software that is simple to understand such that when you or one of your other teammates comes to debug it, because inevitably there will be bugs in software, that's just life, you need to make sure that the code is simple enough such that people can understand what you're doing, and particularly so that you yourself can actually debug it. Now, the next quote here was written in 1972, basically saying that there's a software crisis in 1972, that software had become hard because the machines were really big and really powerful, and we had compilers and programming languages that were sophisticated, and we have a gigantic computers. Programming has become an equally gigantic problem. Now, that was 1972. Fast forward to 2024. You all have iPhones or Android phones. You also have laptops that are way more powerful than anything that Dijkstra experienced in 1972. And the realm of software engineering involves frameworks, it involves languages, and a whole bunch of other technologies, such that software engineering has become an even more gigantic problem, right? So this quote, remarkably, is more relevant now than it was then. The one thing I hope you learn from this course is that good processes lead to good software. And with that in mind, we're going to give you the tools so that your team can learn about what processes work, what don't work, because good processes can lead to good software. Bad processes definitely lead to bad software. Like if there's no process. So basically, the assumption is that if you have good processes, it will reduce your risk and it will lead your team to produce good software. Um, we will talk about software specification and the whole cycle, but basically software specification, which is the first thing is the process of establishing the services that are required and what constraints you can do. So basically, what can you actually build? So, the learning objectives from this course from the calendar are that by the end of this course, you will be able to build a software project as part of a team. This is the backbone of the course. This is what 50% of the grade of this course is based on that. The next objective is that you will use an object-oriented language to develop modular and reusable software. So I am going to be introducing you to TypeScript in this course. TypeScript is a great language because you can write your back end in Node.js and you can run your front end in TypeScript. You can, if you want, build your back end in Java. You will still have to use your front end for TypeScript or something like that, or Python. Once you, for your project, you guys are free to use whatever you want. My exercises and what we'll be talking about are TypeScript because it gives you another language, it prepares you for job interviews, and it's actually a pretty nifty little language. By the end of this course, you should be able to explain design patterns and implement them using an object-oriented language. You will be able to talk about design patterns. I expect you to review 5004 and 5010. I will not be talking about all the design patterns again in this course because you've already done that. You will be using GitHub for submitting all of your assignments and for managing your development. Myself and the TAs will have access to your GitHub repositories. We won't be contributing to them, but we can use those to have a look and see how you're doing. You should be able to describe factors affecting project success and options available for every major process step. You are going to be running an agile team for the whole semester. You're basically going to be running on 1 week sprints essentially. So that will allow you to evaluate that. Your tests, please test your software. If you test your software, it works and you can relax. So these are the learning objectives for this course. What your week will look like, we have 4 holidays on Mondays this week, which will give you a break from me. In class, please bring your computer, sit with your team. We will be instituting a weekly stand-up with your TA, 15 minutes, where you come in and you say what worked this week, what didn't work. You will also be producing a retrospective document for review with the TA. There is no good or bad retrospective document. It's just a way of you self-analyzing. There will be an hour or so of preparatory work for each material. Assignments will be due on Fridays. Retrospectives are due on Fridays. Project presentations will be due in class. Here are some of the resources for the course. You don't have to buy any of these books. There's a lot of materials online. The software engineering books, particularly language-based books, they get out of date really quickly. So if you can't, don't buy the books. The approach for this course, we're going to be mirroring the software engineering lifecycle. We're going to meet with a client. You will be given a brief, and then you'll start with the requirements and testing and deployment, and then you're going to be going through that. So you'll produce an MVP, and then you will have feedback from the client, and then you'll have another 2 weeks to polish it all up, and then you'll be done. Technology, I will be introducing you to TypeScript as the implementation language. You are welcome to use whatever language you want, but it is an opportunity for you to learn TypeScript, which will help you in your career. The course mechanics, I really want to give you an environment where you can learn with your team as part of a larger team. I expect you to all be conversing about the work. I'll be doing some reviews of the lectures in the in-class activities. Your laptop is mandatory in class. In particular, make sure you have a battery that lasts for 2 hours. I will give you slides and videos in advance, and then there will be quizzes about that. The breakdown of the course mark is that 50% of the team project is based on the team project accounts for 50% of the mark. retrospectives. You'll be doing one every week, so that's straightforward. There'll be a project pitch, there'll be a project MVP, minimal viable product, where you will have kind of a workable prototype, and then there will be 2 weeks to fix any issues from that and a project final. Um, the assignments, there will be 5 assignments that you will do as a team. Each one is worth 10. I will use the top 4 marks. That'll give you 40%. Attendance is mandatory. You get a 0.5% per class that you attend, and then you get a quiz to validate the pre-material. Um, that's it. There may be one every week. Some weeks there may not be, especially towards the end of the semester, when you're working on your team projects and stuff like that. It may be that there won't be any class material. So, but the total amount of all of the quizzes will be worth 5%. Feel free to appeal your grades. We'll be marking your assignments and your projects on GradeScope. There'll be a rubric there, so you can see the rubric in advance, and then you'll be able to, if you want, you can ask for a regrade request. Late policy, there is no late policy. There is no extension for the assignments. There is no extension for the projects. Anything that if you do not get an assignment in on time, you get a 0. If you fail to present in class, you will get a 0. The reason that there is no late policy is you are working in teams, and as in real life, if one of your team members is sick or has some other sort of emergency, we expect the team to mitigate that issue and deliver on time. That being said, if there is something that is, if there is an extenuating circumstance, and things really go crazy and your whole team is impacted by something, then reach out to your TA or myself as soon as possible. This is a team-based course. We expect you to work as a team. Don't steal other people's work. If I expect you all to be working as a large body of people, and I expect you to be responsible for building your project. However, I do also expect you to talk to other people, other teams. This is not a competition. I want you all to succeed together. Finally, if you use Copilot, which I expect you to, be careful with their code, Copilot, ChatGPT, they often get it wrong, and I'll have some videos about that. Canvas is going to be where the modules are and the links to all of the course materials. Piazza will be there for discussions. And so I want you to pause and think for a second about what software seniority in software engineering is. But what I'm going to do is I'm going to give you an analogy that allows you to think about what seniority in software engineering means. So let's think of a job of a table clearer or a bus person in a restaurant. A junior bus person or table clearer starts their job off, and then you say to the junior person, take the plates and the cutlery and put them in the kitchen by the sink. And then that's fairly straightforward. Mid-level is please clear the table, and you'll notice that some person may have ordered tea, they may have ordered coffee, a bottle of wine might be on the table. All of these things add ambiguity to the task, and therefore you now need to think a little bit. And the senior table clearer is thinking about the business. So one of the examples that I remember seeing when I was living in Toronto, in Chinatown, there was a large Chinese restaurant that served a huge number of people every Saturday. And so they had optimized the clearing of the tables because they would put about 20 tablecloths, plastic tablecloths, and then they were able to clear the table by picking up the 4 corners of that, picking all the dishes up together, and then taking it away. What I found curious was that they would protect the teapots. So any teapots that were on the table would be picked up first, but then everything else was picked up in a big thing, and they would go off. So they were able to clear the table and set the table in about a minute, and then the next group of people could come in and start eating or ordering. That's what junior. So a junior person does as instructed. A mid-level person or a mid-level software engineer would be able to deal with some ambiguity, and a senior person is thinking about the business and how to drive it forward and how to use software engineering to do that. So, now that you've watched this video, and by the end of the first class, we will have studied this class. We'll have studied what software engineering is, just in general terms. You should understand what your weekly obligations as a student are. You should be part of a team. We'll set the teams up, and you should also be able to talk about the requirements for completing this course. Thank you for watching.